All right. So, a couple things off the top. Try to sync up everybody with the iClicker and upload the first kind of scores from Wednesday. If it showed up as like a 0 or missing for you, there's like a handful, and a couple people reached out via email. So one thing I need to make sure you do is if you have a physical version, remember you have to register it not only under your iClicker account, but also on Canvas, right? So there's this iClicker registration. You need to make sure you enter your remote ID there as well. If you don't, that can prevent it from kind of syncing up. No worries. I collect and I still have all the data. So as soon as we get it registered correctly, I can match it up to your name. All your old scores are there and they'll kind of get uploaded. So don't freak out if you do see a 0 right now and it didn't get quite registered quite correctly. If you just have the app version and you're having issues getting synced up, then reach out to me because I'll probably have to do a little more troubleshooting there. I think there's like 1 or 2 people I can see. For some reason it says self drops. It may just be that you have to register for the course on the app again. Searching through Ball State, the institution of Ball State, and then kind of finding this the course in a second. Okay. I also put up the first Excel assignment. So we'll probably finish up everything for that today, I would think. Maybe we'll bleed into Monday a little bit, but you can make a pretty good, take a pretty good chunk out of it. The stuff that we did last class is really the bulk of that assignment. And then the last question or two is some stuff that we'll probably get to today, like I mentioned. That Connect assignment, kind of similar, like we probably haven't covered everything for it, but you'll probably be able to get at least do like probably like half of it. I would kind of estimate. I don't know if it's exactly half, but I broke the questions down, but something along those lines. Okay. Any other questions for me before we kind of jump into material today? Yeah.
So when you type in the thing, put register just and it like goes like that means you're good and registered.
Yeah, so it should show up on your iClicker account that you have registered whatever your remote is, and then on Canvas once you register it once, then it should be automatic. Okay. And I'll have to resync them after class. Like if you just did it, like it's not going to show up instantly. I'm going to have to go into the apps and sync everything back up. Yeah. See another question somewhere over here. Yeah.
Yeah. The previous stuff you've been working on with the Excel is it going to be in accessible?
Yep. So if we go here to in-class data, this in-class, I've been updating this, so this should be like everything we did up to this date, and then we'll do a little more on it today, and I'll re-upload it this afternoon as well. Yep.
Thank you.
Any other questions before we jump into material here? Get things out of the way. All right. So, well, let me think if I want to jump right into Excel. Let's see. We already worked through some of this last class. So just kind of a recap. And I've got some slides up here that kind of remind us what we did last class. So we went through some continuous data. We created bins, that minimum maximum column. We then kind of got our frequencies with the count ifs formula. If we simply selected those frequencies, inserted a bar or a column graph, we said that's going to be a histogram, right? This column or bar graph that shows our frequency distribution. It's really just a fancy name histogram that says we started out with continuous data. We threw it into these bins in order to kind of give you a nice visual of what that frequency distribution looks like. We could use the frequencies. We could use our relative or our percent frequencies as well. We kind of already mentioned this shouldn't change the graph, right? Because we're dividing and multiplying by the same number. So the relative size of these groups shouldn't change. That's kind of where we left off. You don't have to use kind of these bar graphs. You could do a line graph. I don't know, frequency polygons. It's still showing you the same thing. I think more often than not, people use a bar graph to kind of, it makes it real nice, easy to see the different categories. But because you do have truly continuous data, you do have like multiple observations in this range. Sometimes people like to put it into a line graph, but still conveys the same information. The majority or the highest frequency of our observations are in the middle here. It's kind of hard to see, but like 15,000 to 20,000 is the net tuition price. There's some, smaller number of universities that are kind of really low and really high, right? So the next idea would be to come up with this cumulative frequency. So we'll go back to Excel and we'll see where we left off. So actually, I forgot. I think I maybe went a little bit faster in the second section. And we did percent relative frequencies, which we didn't do last class. So we had our relative frequencies, right? So those should add up to 1. How would I get my percent relative frequencies? simply,
Multiplied by 100.
yeah. So what I could do is just take that relative frequency, multiply it by 100. Now, when I copy this down, 08 becomes 09, 010, et cetera, et cetera. So really, I'm going to type this in one time. Now, a nice little shortcut, instead of like left clicking and dragging this down, if you have data set up like this, and then you do with one entry in that very first cell, if I get down here to I have this black thick plus sign, I double left click, it'll copy that down where it updates the cell references all the way down to the very last place that I have data. Now here, these I don't really want necessarily to be there, so I might go a little bit too far, but double clicking there is a kind of a nice, easy way instead of dragging it down. Now for only 8 bins or whatever, that doesn't really matter, but if I wanted to do this for something in my data, like thousands, that double left click becomes pretty helpful, okay? Any questions on that? It shouldn't be too bad. Now, if I add up these percent relative frequencies using that sum function, right? What should these add up to? We kind of already saw it, but
100.
huh?
100.
Yeah, 100%, right? We kind of said the relative frequencies add up to 1 because we counted the entire proportion of the data. The proportion is 1, it's whole. We're talking about in percentages, right? We move the decimal 2 places. This should add up to 100% of the data has been counted. Okay. Questions on that? Shouldn't be too bad. So here is kind of a new idea, right, that we haven't really talked about yet. And I'll kind of use something that I think all of you probably have some idea about to introduce this. So if we want to come up with cumulative frequencies, right, it's just like your GPA. You have your GPA this semester, or in any given semester, but you also have a cumulative GPA, which does what? Takes into consideration this semester all the way back to the beginning of time, or the beginning of when you came to college, right? And so this idea of cumulative is saying, okay, from this bin, count the number of observations in this bin, plus every other bin below it. So for that very first one, it'll almost be like I actually want the frequency in that first bin, but every bin below it. But for the first bin, there's no bins below it. So the cumulative frequency for the very first bin, 0 to 5,000, is actually going to be just whatever it is. Let's see, 69, right? So whatever the first bin's frequency is, that's also going to be its cumulative frequency. For the first bin, really shouldn't be too bad, right? Okay. For the second bin, what we're really saying is, okay, how many observations were in between 5 and 10,000, plus all the observations that were below that. So really what I'm saying, what's the observation in between 5 and 10,000, and how many observations were between 0 and 5,000? Or another way of saying that is really, how many of them were less than 10,000? Right? So one way I could do this in Excel is, okay, take the frequency of this bin and add to that the frequency of all the bins below it. Well, there's only one bin below it. Okay. Now don't copy this down yet, because we're actually going to replace that. This is just the first way I'm going to describe it to you. We'll kind of go back and show you a quicker way of doing this, but that's the idea. Now, for the third bin, it would then be, okay, how many observations were between 10 and 15,000, plus how many observations were below that? So how many observations were in both of these bins? We'd really be adding up all these frequencies, right? I don't know if I can do this in my head, but really that third bin, we're saying how many of the observations were less than 15,000. Right? So I would say, okay, take the frequency of this bin plus every bin below it, right? And once I hit enter here, I get my cumulative frequency, okay? Any questions just on the idea of what we're doing here? Shouldn't be too bad. So the next thing is where I can show you this quickly, because you can imagine every single time, I don't want to have to go, okay, take the frequency of this bin plus this and this and this. And then the next one, I go, okay, take the frequency of this bin plus this and this. There's one way we can do this very quickly that'll always work for us. So the thing about here, I'll try to give you a nice visual. Maybe I drew this too far. So for this first one, what? 69, 291, And this one's what, 639. So if I just had the frequencies graphed out here, and I then want to think about, all right, I'm doing my cumulative frequencies over here. Right? For the very first bin, the cumulative, frequency was just, well, there's no bins below it, so it's just the frequency of that first bin. Right? We kind of already had here that second bin, we said the cumulative frequency was 360. Right? So what was the difference in between the cumulative frequency for that first and that second bin? So this included the number of observations that were between 0 and 5,000, but then it added to that the number of observations that were in between 5 and 10,000. So you kind of think about it, your cumulative frequencies, and if we go to the third one, and I'll get out of the way in a second. This was what, 999? But you can kind of think about this was really taking the frequency from that first bin, frequency from the second bin, and then adding to it the frequency from that third bin. Okay? So this cumulative frequency, the bar should continually be getting higher and higher. In fact, by the time I get to the very last bin, what should my cumulative frequency actually be? So once I get to this last bin, this was the one where we said it was greater than, I guess I should maybe scroll over so we can see the label, might make a little more sense. There we go. Greater than 35,000, right? So this would say, okay, how many observations are greater than 35,000 or anything below that? That would have to be every observation, right? I mean, if you're talking about how many observations have a value above 35,000 or below 35,000, well, that's every single number, right? So by the time I get to my very last bin, my cumulative frequency, hopefully, should be that total number of observations, right? Once I get to the last bin, all of the data should be in that bin or any bin below it, okay? So another way I could do these cumulative frequencies, kind of using this idea, notice every cumulative frequency is the frequency of the current bin you're looking at plus all the bins below it. Frequency of the current bin you're looking at plus every bin below it. Right? So what that would look like if we're using cell references. So we'll go delete these. We'll have the first bin. For that second bin, we'll say, okay, look, take the frequency of this bin, right? How many observations are in between these two values, plus how many observations were below this. Well, if I go back to the previous bin, it tells me the cumulative frequency would tell me the number of observations in that bin or anything below it. So if I simply kind of take the frequency of that second bin, add to that, oh, I forgot to set this up, add to that kind of the cell before it, that cumulative frequency of the bin before it, this should always, we'll kind of just for these first two, be giving me the correct answers, or exactly what I was doing before when I was like adding every individual component. Right? So if I simply take the frequency of the bin that I'm looking at, plus the cumulative frequency of the bin before it, that should always give me the correct cumulative frequency. Now, when I copy this down, it'll update to be the next bin. Okay, take the frequency of this bin, plus Q8 would then become Q9, the cumulative frequency of the bin before it. So if I copy this down, hopefully when I get to the bottom here, I'll have my total number of observations. Right? And kind of be a nice check to make sure that I did everything correctly with the cumulative frequencies. Now, we're not asking you cumulative frequencies on the Excel homework. So I know sometimes people look at what we've done in class and use it as a template. You should do that. That's great. That's an easy way to get through the assignment. But just because we did something in class, I may not necessarily ask you to do that on the homework, right? But I think what I have you do is do up to relative frequencies and then graph those relative frequencies. But this idea of cumulative, we'll kind of keep using it throughout the semester. So I like to try to introduce it here. Right? And you'll also see graphs sometimes that have these cumulative frequencies. You know, you can imagine it's very similar to what we did last class. So if I select my labels that I had, hold Control or Command on a Mac, select my cumulative frequencies, go to Insert. Usually cumulative frequencies will kind of see a line graph used. So it kind of shows like initially, you know, there's not a lot of observations at these low values, right? Very low net tuition amounts. There's not a lot of schools down there. but then very quickly it starts to rise kind of in the middle there, and then kind of approaches, all of, the full number of observations, right? Kind of levels off there once we get to these higher amounts. Okay. So this kind of depends on the question or the information you're trying to convey. A lot of times we just like to see the frequency distribution, but sometimes we want to know the cumulative frequency as well. Okay. Excuse me. So I'll delete that for a second. Any questions over anything up to this point? You want to see something again or a question on anything I said? All right with that? Yeah. Okay. So, where was I? Oh, so I think, I have some stuff in the slides here. I think that technically I'm not going to expect you those, but these cumulative frequency polygons are called OGIVs, which I didn't know until I started teaching this class. I just always called them cumulative frequency graphs, but I guess there's a specific name for them. So we'll see these used from time to time, kind of have the nice visual that we created already. So the next thing that we're going to do is start looking at some other graphs we can do in Excel, and we can do them pretty quickly. Right. So come back here, I believe. Actually, well, I walk through the example in the slide, and then we'll kind of go back to Excel just to kind of get a little bit of kind of back and forth. So up to this point, we've been looking at one variable, whether it was qualitative, whether it was quantitative and discrete, or quantitative and continuous, right? We then show, okay, we can come up with these frequency distributions to kind of show where the majority of the observations lie. Sometimes we'll do things with not just one variable, but two variables, right? So the kind of visual that we'll look at for that is a scatter plot, and this will become, actually, we'll reference this really almost like in the last couple of weeks of the class. We'll kind of come back to this, but for now, we'll just kind of start out with the idea. If I have two variables, I might be interested in, okay, as one of these goes up, right, as one of these variables increases, what's happening to the other variable, right? So we'll use a scatter plot to get at this. So let's say I had like years of education and income, something like that. What I would do is say, okay, look, take the years of education someone has, make that my x-axis variable, take their income, that's their y-axis variable. I've got this data set with maybe 1,000 different individuals. I've got how many years of education they had and what their income was. So for the very first person, whatever their education level was and whatever their income, I plot that. I then go to the second observation. I take whatever their education income was, I plot that. Third person, fourth, right? I plot all these 1,000 different observations. Right? Well, here, like if it looks something like this, I could probably think about, and you might have, hopefully talk about these things in like some type of science or math class. I could think about there's probably a line that kind of best fits that data, right? Now that line would tell me, if it's upward sloping, it looks like this data that as education goes up, income tends to get higher as well, right? Or whatever the two variables are. And if that line is sloping down, well, there's a negative relationship, right? As that x-axis variable goes up, the y-axis variable starts to fall. So that's all a scatter plot is we're just plotting every single observation, right? So, excuse me, I've got some data here. We'll look at some different data in Excel where I've got a bigger data set, just kind of show you like we can do this with anything. So I have different countries. I have their life expectancy and health expenditures per capita, which also I might go on the side here in a second. But so we've got all these countries. We have their life expectancy. I might think, okay, if they're spending more money on their health, right, then hopefully life expectancy would be higher, right? I think there's probably a positive relationship between these two variables, but I don't know. I'll get a nice quick visual by creating this scatter plot, right? So if I plot every single country, healthcare expenditures and their life expectancy from that table or from that data on a graph, I get something like this, right? Now for this one, I guess, if you told me the line of best fit is like, maybe kind of slightly upward sloping, right? But you've also got these weird outliers here. Like, I don't really know if there's any real correlation, right? Or at least there's not an obvious one. If it looks something more like this, what looks like there's a very obvious correlation between those two variables. Here, I don't get something that looks quite as obvious, right? If I had to say, like I said, maybe there's a slight increasing line here, but it's hard to really get a line that, looks like there's a very obvious direct relationship here. Right? But this is the idea of a scatter plot, right? And it kind of lets me know that very quickly, right? You can imagine another example would be something like, just to kind of give a visual. Let's say I had, something like this. Well, this is very clear that there's a negative relationship between whatever X and Y variable that is. Okay. So this is, I don't know, this one's kind of interesting, the idea of like, I think this is the US, if I remember right. It's like, even though we're spending way more on our healthcare, I think I have these, hold on. Yeah, there we go. Even though we're spending way more on our healthcare, our life expectancy is like below every single other OECD country except for Poland, right? So maybe we're, these two things are correlated. Maybe it's that spending more on your healthcare, you're not doing that to be preventative, but you're doing that because you're sick and you're not doing so well, right? So that maybe is kind of the indicator that we have in the United States. But you have to dive deeper in it to really get that. But that's a scatter plot. It gives a nice kind of quick idea about what the relationship between our X and our Y axis variable. Right? So here's another one. I think I'll create this one. This is the data that I have in Excel, so we'll create this in just a second. I don't know. I had this laying around. I'm kind of over the COVID stuff, but I know it still exists. So I talked about a little bit. But I believe this was, I've got my X-axis variable was the percent of, I think I had state level data. It looks like there's about 50 observations here. The percent of that state that was vaccinated, and then kind of the number of, I believe this was cases per 100,000 people, right? So if I'm trying to draw a line that best fits this data, I don't know. It's kind of hard to say. It's probably pretty flat. Like there's, states that have really high percent vaccinated and low cases, but there's some that have a high percent vaccinated and high cases, kind of the same on the other end. So there's probably not a whole lot I can really kind of come up with. This data doesn't look like there's really not an obvious relationship between getting a higher percent of your population vaccinated and kind of the number of cases your state's going to see, right? So one reason why this, and this was kind of like older data, I think when there was still like, we're just out of restrictions. So you can kind of think about why sometimes we get these, like they might seem confusing, like in your head, like, well, more people are getting vaccinated, and we see fewer cases. But if everybody's vaccinated, what do you think people are more likely to do, especially when this was still kind of like, I guess, at the height of the pandemic? Go out and do things that I wasn't doing before, right? So even though you have more people vaccinated, it's also changing their behaviors. So maybe you actually see the number of cases go up, right? So this can kind of just give us a quick snapshot of something like that. If we go to Excel, how would I actually create that graph? So I've got the COVID data worksheet down here. I think before we were over here. So I'll select that worksheet. All I'm going to do to create that, I'm going to select my two variables, hold Control Shift or Command on a Mac, hit the down arrow, right? I've just selected those two columns of data. I'll then go to Insert, and there's this option here, which is a scatter or bubble chart. But we just want a scatter plot, right? So the very first one. And that's basically the graph that I was just showing you in the slides, right? It's that easy to create these scatter plots, right? Now you can go in and like add labels to the X and Y axis, which makes it a little bit more helpful, right? Because then you can kind of see, like, I don't really know what these two variables are. So I go up to this plus sign. I can go to axis titles. I can then kind of type in, percent vaccinated or whatever I want to make the graph look a little bit prettier and to convey the information a little bit better. All I'm trying to show you how to do is how do we take the data and get into the graph? If you want to make the graph, add more things into it, that's kind of specific to the problem and pretty, you could probably Google search how to add in axis labels to Excel and figure it out pretty quickly, right? Any questions on this before you keep moving here? And having problems with anything? So that's pretty easy, nice scatter plot data. The next thing we'll talk about is maybe I've got time series data. I mentioned this briefly last week, but if you have time series data, I've got one subject, so the US here, and I'm collecting information on the variable unemployment rate at various points in time. Right? Well, what's really nice with this time series data is to create like a timeline graph, right? So in the first Excel assignment, I've got how you would do this, but I'll actually just show it to you right now, and then we'll kind of go back to the slide. So if I go into that Excel document again, instead of the COVID data, let's go over here to unemployment. All right, so I've got the unemployment rate in the US for the last, 17 or however many years here. What I'm going to do is select my unemployment rate. And you might think you could select the year and the unemployment rate. I then go to insert a line graph. The problem is here, if you do it this way, it treats the year like it's a different variable. It's not going to simply use it as kind of your x-axis values. You know, ideally what we want from this time series graph is, so I want my year down here. I want my unemployment rate. So I'd have like 2005. Where was the unemployment rate? 2006. Where was the unemployment rate? 2007. Right? And I would kind of get this nice kind of time series graph. The problem is, like I said, it's treating the year as a second variable. So what we have to do with these time series graphs is only select whatever's changing, whatever the variable you're trying to kind of plot is. Here, the variable we're trying to plot is the unemployment rate. Now, when we go to insert and we go to this line graph option, now we get kind of this nice time series graph. Just like I think I showed you last week, the issue is we don't want these to be our x-axis labels. So if we right click, go to select data, and I'll Google this afternoon and I'll post an announcement on Canvas, because I know on some Macs there's an issue of when you right click, it doesn't give you the select data option, and I forget exactly off the top of my head. I think you have to go chart options and then it should have it, or maybe it is just if you do have the select data, there should be something that kind of has these horizontal axis labels. It just looks a little bit different than this. It's like a bigger box, and I think it's like down towards the bottom, right? But if you're kind of having issues with that in the Mac, I'll kind of post an announcement on my Canvas to how we kind of can get in, not just numbers here on the x-axis, but we want the actual years, right? So when I right click, and actually, sorry, I have to right click on these numbers, then go to select data. Now, when I see my axis label, I can edit. I then just select, well, what are the labels I want? I want it to be these years. Now it throws those years in there for me. Now, if I zoom in a little bit, well, maybe I zoomed in too much. Let's go 150 here. Okay. Now I've kind of got those years down there, and I can get a really quick story from this data, right? I can say, look, unemployment was relatively low in the mid-2000s. It then spiked around the financial crisis of 2008, 2009. It then kind of progressed, just a steady decrease all the way up into about 2019. And then in 2020, what happened? A lot of people were forced to be unemployed, right? So I saw this huge spike in unemployment, and then it's kind of decreased from there back to pretty much where it was at pre-pandemic, right? If you imagine like the pandemic didn't occur, right, this line looks like it would be kind of right about where it ended up being today. Okay. Any questions on this? Right, and actually, it's kind of interesting. This is not necessarily a physical point, right? We're actually at unemployment rates lower than where we were at when things were good in the kind of mid-2000s, right? Any questions on anything we've done here in Excel before I keep moving? So this should actually, this is why I don't know why I didn't think we'd have as much time, but this should be the last thing that you need to do in Excel, right? Or in the Excel homework. Now, what it does have you do is something that I didn't do here, but I'll show you that it's very easy and it wouldn't take any more time. So let's say, I don't know, here's the United States unemployment rate and Canada, right? I didn't waste the time to look up Canada's unemployment rate, but I just want to show you that if we had multiple variables, we can actually graph multiple variables on a time series graph, right? So I'm just going to make up some values here. Oops. And just graph a few of them. So if I had two variables and I want to create a time series graph for both unemployment rate in the United States, but also the unemployment rate in Canada, all I would do is select both of those countries, insert my line graph, and I now get both of those on the same graph. All right. Now, probably helpful here that I didn't do is notice it tries to put in a legend that says series 1 and series 2. Well, what does that mean, right? Well, if I delete this, and instead of just selecting the data, if I select the labels as well, Now, when I go to insert that line graph, notice it's kind of letting me know which of these lines this is in the United States or my first variable and which of them is the second variable of Canada's unemployment. Right? So selecting the labels there kind of makes a nicer graph or easier to understand. Okay. Any questions before we keep moving here? And I just kind of, the numbers I chose, it looks like these two kind of mimic each other, right? But if one was like way higher, and for example, here, I can then very quickly compare, like across this time period, the United States always had a higher unemployment rate than Canada. They followed kind of similar trends, but one was always higher, right? So I think on the last question, I give you some stock price data and have three companies, and you kind of graph what their stock price was doing over that time period. And then you can kind of compare those different countries, like which one had the highest stock price, was one of them increasing over this time period faster than another, or was one of them even decreasing? And you can get that really quickly from this nice timeline or this time series graph. Okay. Any questions on this before we keep moving here? All right, this stuff shouldn't be, I don't think, too terribly tough. No. Yeah, 20 minutes. Hopefully we can get through this. If not, we'll probably have to finish this on Friday, finish this next week on Monday. So we've graphed all these frequency distributions along with some other things. So these frequency distributions are kind of giving us an idea about where the majority of the observations lie. Like what's the most common values that we see these observations being, right? We've got different types of distributions when we start to look at it. So I'll show you a couple examples. So one I had here, and I believe this was that I-STEP score data. So this was like different schools, what their I-STEP scores were. If I were to kind of create a nice frequency distribution for this, we would call this, and we'll kind of really hammer on this about another, I don't know, third, I guess, of the class. If it kind of looks like if I were to trace out the tops of all these bars, it looks like it would kind of have like this bell shape. We would call this a bell curve or a normal distribution, right? Where the majority of my observations are kind of all here in the middle. And then as I move away from that middle part of the data in either direction, seeing extremely high or extremely low values, I start to see fewer and fewer of those, right? The bars start to decrease. Remember, the bars are telling me the frequency for each one of those bins, or the number of observations I see in between, for example, here at 550 and 560. Okay? So that's a nice, once I have these frequency distributions, I can see, okay, the majority of the data is in the middle here. Very few observations that kind of are extremely different from that, right? Or this kind of nice normal curve or bell-shaped curve. If I had something like income data in the US, this is older income data, but it looks pretty similar. Now notice here, they create these bins of like 5,000. Well, the problem is once you get up to like 250,000, you might want to create some catch-all categories. So they did like a 200 to 250, and then over 250,000. Now you could kind of continue to extend this graph by $5,000 bins all the way up to, into the millions. But instead they just kind of said, look, there's here's all the people that are making kind of these higher amounts of income. What we can kind of see here is, well, the majority of the observations, or the majority of households, have relatively low income amounts, right? That's where we see the highest bars. And then kind of these higher amounts for income, we start to see that there's fewer and fewer people earning these higher income levels, right? And like I said, if we really wanted to kind of extend this to a whole bunch of bins, we would see that it really just has this tail that kind of tapers down towards zero, right? There's fewer and fewer people making, 250,000, 350,000, 450,000, right? Those frequencies are just decreasing. So if we saw something like this, where the majority of our observations are over here on the left side, but we get this kind of long right tail, we would call this a right skewed distribution, right? So anytime we have kind of a long right tail, if we were to map out the tops of our frequencies or to map out this distribution, we would call this a right skewed distribution. Now, there's a better reason why we're calling it right skewed, and that's what I think we'll probably have to hold off until Monday to really get at. But this, for right now, just know if you see a long right tail, right skewed distribution. Okay. I have length of a pregnancy here, or gestation, the number of weeks. So here we kind of we map out a line that kind of hits the top of all of these bars. Well, now I've got kind of this longer left tail. We would call this a left skewed distribution, right? We see premature births. We don't see like babies born at like 11 and 12 months, right? So we kind of have no right tail here, but a long left tail. So we've got normal, right, left skewed distributions. We might also have something that looks bimodal, right? So I've got an old graph of body weight, basically. Now, if I look at this, it looks like if I were to map out this distribution, I almost have like two normal distributions here, right? So we see the normal distribution pop up a lot in nature, a lot of biometrics. So if I'm looking at weight, why might I kind of see what looks like two normal distributions here? What's maybe a characteristic that would predict kind of difference in just the average of weights? So this is probably my kind of male weights, and this would be kind of my female weights, right? So a lot of the times when we see this bimodal distribution, that should signal to me, okay, look, I have like two distinct, I shouldn't say populations, but I have two characteristics that's kind of separating the data, causing some of it to have a higher mean, shifting that distribution over, and one of them to have a lower mean, right? If I were to like, for about maybe an example, it's not, I don't know, male, female. If we do, let's say I take the income in the US and I graph that out, it's not normal, but it's kind of right skewed. But then I also had, what country am I going to do this? Let's say, I don't know, Romania, right? And I graph out their income distribution. It's going to look like I have two separate distributions, right? Because the average income in Romania is going to be significantly lower, where I'm kind of seeing the majority of incomes be in the United States, right? So anytime I have a characteristic that's kind of separating my data into two groups, I might see what looks like this kind of bimodal distribution. Okay. Any questions on that before we can keep moving here? All right, so hopefully what we're gonna do next is easy and kind of almost like a review for a lot of you, right? So we've come up with these frequency distributions, and I already kind of started mentioning when we're looking at them. Well, where's the middle part of the data, right? Where's the average? Right? We probably, hopefully, at some point in time, calculated an average before, right? And so we want to come up with different metrics, the average being one of them, although we'll kind of give it a different name, of central tendency, or where does the middle part of that data lie, right? If I'm looking across every single observations, where's kind of the middle value? So we've got three different measures, and we'll start to use a little bit more notation as we just progress throughout the semester. Right? So more often than not, 99% of the time, we're gonna have to, 99% of the time, when we write out what the population statistic is, we're gonna use Greek lettering. We write out the sample statistic. We use kind of our English alphanumeric or alpha numeric value, or like X, S, R, right? There's different letters, right? English letters. Okay? So here, I have to make a difference between population and sample data sets. My population mean is going to be this Greek letter mu. My sample mean is going to be this regular letter that we recognize, and we just put a bar over the top of it, right? Or X bar. Okay? So population, sample mean. Okay? Now for the median and the mode, we don't usually indicate whether or not it's a population or a sample, but if we really wanted you to be complete here, so I've got my median and my mode. This would be for my population. If I wanted to write them out for my sample, we're just gonna make them lower cases. So that's not, I don't think that's gonna be, and the way that we come up with the median and the mode doesn't vary between looking at population and sample data. We'll talk a little bit, we'll use some different notation when we talk about calculating the mean for a population versus the mean for a sample. Although the procedure is going to be exactly the same, we'll kind of use slightly different notation for things that we're going to do further on kind of down the road. But mean, median, and mode. We'll talk a little more about these here in just a second. We've also got measures of variation, right, which we'll talk about next week. So the variance and the standard deviation. The variance for our population, we're going to write as sigma, right, the Greek letter sigma squared. Right? And that's when you're saying this is a sigma, there's upper and lower cases. So you probably use a thing like the Greek, but the uppercase sigma, this is lowercase, right? So here's our Greek lettering, here's our variance sigma squared. For our sample, it's F squared, right? Sample variance is just F squared, right? A non-Greek lettering. And then the standard deviation, we're just scaling the variance. It's just sigma and S, right? So how can I get the variance from the standard deviation? Simply square the standard deviation, right? And we'll talk about why we scale it that way next week. But for now, I'm just kind of introducing to you to some of this notation, okay? Any questions here before? So, first one, how do we find the mean, right? I'll show you the kind of real mathematical way of writing this, and then we'll just talk about what it actually you would do in practice. So, how if you were to explain to me in words, how would you find the average of like 10 numbers? Add them up divided by 10, right? Hopefully that's not a wild idea or, a wildly new idea to anyone, right? But the idea that we could write this out is what we're really doing when we have a variable to find that population mean is I'm taking the very first observation, the value I see for that variable X, adding to that the second observation value for X, adding that to the third, right? Just adding up every single observation value for this variable. And then when I get to the very end, I then divide that by the total number of observations that I had, right? The total number of numbers that I added up. So capital N here will be our total number of observations in our population data set. Now, another way of writing this, right? Instead of writing X1 plus X2 all the way up to, thousands, right? And I want to write that out. The capital sigma, right? This is what we call our summation sign. So all this means, and we're only going to ever use it to kind of say, start at the first observation, go to the very last observation. Right? All this summation sign is ever going to mean for us is do whatever's to the right of that summation sign for every single observation and add them up. Well, here, it's basically just take the value for every single observation and add them all up. That's all that summation sign is telling us. So if I were to write it out individually, it would look something like this. Any questions on that? And you can use the summation sign as different things, but for the sake of what we're doing in this for this course, it's always just going to mean do whatever is to the right of that summation sign for every observation and then add them all up. Right? And then, of course, to get our mean, we then have to divide by the total number of observations that we added up. Okay. So our sample mean is going to be the exact same thing. We'll just use slightly different notation. So the only thing that changes here is we start using lowercase n, right? And lowercase n just represents this is the number of observations in my sample data. Right? Our samples are always smaller than the population, so lowercase n for the sample, uppercase n for the population. So we wanted to mean birth weight, and I had some data laying around that was like every birth in the United States. All I would do is add up all those birth weights and then divide by the total number of births that I see in that data set. Right? And like I said, this is hopefully not a wildly new idea, but introducing some of this different notation that we're going to kind of use moving forward might be a little bit trickier, might be a little bit new. Okay. Any questions over anything up here, or even going back here on any of the notation that maybe hopefully I think I got everything, but if I didn't say something or you missed something. Okay. So I think I had some data and we actually find this. So if I had like an example here where I wanted to find a mean and I've got the points scored, right, in some game, this could be basketball, bottle, I don't know, it doesn't matter, right? But I want to find the mean or the average kind of points scored. So when I said before, a lot of you probably heard of the term average, it's being a little bit lazy, right? The average is kind of telling us where that middle part of the data is. Be very specific about the statistic we're calculating. We're really calculating the mean, right? That's kind of the technical term for it, but we can kind of use those interchangeably. If you're talking to like the general public, if you're trying to get some, you probably don't want to use the word mean. They might not know what that means. You probably want to use the word average, right? That's more of a kind of term that we use. So if I want to find the mean or the average, all I'm doing is adding up all these values and then dividing it by, well, how many observations do I have here? 7, right? Hopefully this is relatively quick and easy for us to do. Any questions about calculating a mean here? All right, so hopefully this is a real easy one. we get everybody, hopefully, to get this correct. So if I wanted you to instead, here's an or a data set with 7 observations, and here's 7 different commute times. If I wanted you to find the mean commute time for this data set, what would it be? So I'll give you 2-3 minutes to kind of come up with this. This also might kind of help point out that it's probably helpful to have a calculator in class. If you pull it up on your phone, that's probably okay. But kind of down the road, we'll be doing some calculations a little bit more difficult to do on your phone calculators, unless you download. There's actually like scientific calculator apps you can download. So like if you don't have like a TI 80, whatever it is, you can actually download a pretty similar version to give your app store. But for us today, this shouldn't be too bad to do on your phone calculator either. So like I said, about 2 minutes here, and then we'll kind of talk about this. Whenever I give you these, talk to the people around you. You know, for this one, it probably won't be too bad, but you might they may be able to help you out with the. Yeah, the 3 weeks.
He's only given the number. Yeah, always. I'm sorry. Me and you just didn't call anything rules. You're going back. Standing in the speed. 1 4 1 2
All right. Everybody get an answer in here. 32 of us. All right, and close it out. Oops, not that one. This one. Oh, got someone in at the end. So, how do I do this? Okay, well, we were close, but how should we do this, right? All we're going to do is take every single observation, right? 20 plus 35 plus 9 plus 45 plus 40 plus 35 plus 50. Add those all up and then divide by the number of observations we have here, which is kind of easy to see. We've got 7 different commuters. We should get 45. Okay. So generally that's how I'll do. We'll work through one in class. So then can I ask you one? This one hopefully wasn't too bad. Now, one thing that we can I wanted to point out here. Let's say one of the possible answers was something like this. Right? Why could I rule that out right away? So think about what we're trying to do. We're trying to find the middle part of this data set, right? The middle value. Why can I rule this out? Yeah, right. That value is greater than the maximum, right? I know my mean has to be somewhere between the minimum and maximum. So here it has to be somewhere between 20 and 90. So when we're doing this, doing these calculations, I'm getting these entered in my calculator, I'm adding up all these numbers. Maybe I forgot to add one of the numbers in, or I accidentally entered in one of the numbers twice and I get a larger value. Well, very quickly by then stop. Okay, I did the computation in my calculator, but let's think about the statistic that we're actually trying to calculate. Let's think about what makes sense. I know before I even start to work on this problem that the value I should get is somewhere between 20 and 90, somewhere in between this minimum and maximum. If I make a mistake and somehow come up with something like 120, well, very quickly I can say I did something wrong. Right? I know that it has to be somewhere between 20 and 90, so I made an egregious mistake. Maybe I hit, instead of 20, I hit 200 or something when I was entering in that value. Okay. So always kind of think about what answers might you be able to rule out. Here we can't really rule out any of them. But a lot of the times we think about when we're coming up with a value, we at least can kind of put it within a range, right? Especially for the mean here. Right? All right. So next class, we'll kind of finish central tendency on Monday. Let's talk about the median and the mode. I'll then review the distributions and we'll also start varying. Okay? All right. Have a fun, safe weekend. We'll see you guys on Monday.